is the rate at which electrical energy is transferred or transformed in an electric circuit. Voltage is the measure of the electric pressure at which electricity flows through a system. Current, an electric current, is a flow of charged particles. Resistor, a passive two-terminal electrical component that implements electrical resistance as a circuit element. Resistance is a measure of the opposition to current flow in an electrical circuit. Circuit is a closed loop that electrons can travel in. A source of electricity, such as battery, provides electrical energy in the circuit. Power supply is an electrical device that supplies electrical power to an electrical load. Lastly, power consumption refers to the electrical energy per unit time. It is usually measured in units of watts or kilowatts.
Hey everybody, so I thought I'd do another power type of problem, something a little more complicated than what I've shown in the past. So let's take a look at the circuit, and as you can notice we have 4 different elements in the circuit. What we want to do in this problem is find out the power consumed or power supplied by each of these 4 components. So let's go ahead and label each of them so we know what we're solving for. So let's call this guy P1. It's a power source, right? So this is going to be calculating power supplied. This is a resistor, and let's call the power consumed by that guy P2. Here's another resistor. Let's say the power consumed by that we'll label as P3. And this is a current-controlled current source. So the idea here is that it's a source of current, so it's supplying power to the system. The amount of current it supplies is based upon I. It's based upon the current being supplied by that source. So let's go ahead and call this guy P4. So we have 4 different powers to solve. Power supplied by this dude, power consumed by that resistor, power consumed by that resistor, and then power supplied by that source, that energy source, that current source. So let's take these one at a time. P1, so let's solve for P1. Let's choose red. Does red sound good? P1, well we know power equals voltage times current. We know the voltage. Hey, look at that. 20 volts is supplied by this guy. But notice that the current being drawn is going out of it. Usually we talk about current going from the positive to negative terminals, from positive potential to negative potential. So if we're going to say the current is going out of this, let's go ahead and indicate that power is leaving, right, sourced by this, by saying that the current is minus 5 amps, right? That's going to give us negative 100 watts. And we're using this minus sign just to indicate that the power is leaving. It's not being consumed by this, it's being supplied by it. So we're going to indicate that by saying minus. Because usually when something's being consumed, or at least in convention, when something's being consumed, we'll usually refer to it as a positive power. So for instance, for P2, the voltage across that resistor is 12 volts, and the current going through there is 5 amps. And we're going to say positive 5 because it's flowing in the direction we think it's going to flow, from the highest potential to the lower potential. That gives us 60 watts. So this is 60 watts consumed or absorbed by that guy. Down through here, P3, we know 6 amps flows this way, and we know that there's an 8 volt drop across it. So that is 48 watts absorbed or consumed by that resistor. And lastly, P4, which is going to be the current supplied by this guy. Well, we know that the voltage drop across here is 8 volts. right? Because if you take a look at the node, this is the same node. This is the same node here, same node. So if the voltage across here is 8 volts, that means the voltage across here is also 8 volts. You get an ohm meter, you put it across there, that's telling you what it is, what the voltage drop is across anything in parallel. So 8 volts times the current. Okay, now think about what we just said about convention. We're going to say voltage is going this way, right? The potential goes from higher to lower this way, so 8 volt drop across here. But we're saying the current is flowing that way, at least the way it's drawn. So this is going to be a negative current, 0.2 I. And we know I, oops, you can't see that, can you? We know I is our original 5 amps, right up there. Right, I equals 5 amps. So we put our 5 in place of the I. So 8 times negative 0.2 times 5. That gives us minus 8 watts. So that's the amount of power being supplied by that guy. And if people are just looking at our numbers and we tell them, yeah, positive wattage refers to power consumed, then they will automatically know that whenever they see a negative power, it refers to something that's giving out power, something that's supplying energy to the system. So there we go. 4 different elements, and we were able to calculate the power consumed and power supplied by each of the 4. Hope that helps. Good luck in any tests or quizzes you may have with regards to power, or if you're just trying not to blow something up in your garage.